Well, hey there. Hi, this is Mark D'Antonio on the SkyTour LiveStream. Hey, I spent some time tonight aligning the scope, and every target I've been looking for has been coming in just beautifully. So I figured I would give a little stream to try and get going on this for a bit, and I will now see if we can go to town on this stream. So this object we're looking at is actually a little tiny globular cluster. Now, it's a full moon, so it's not going to be that great. When we look at clusters of stars, this will actually help us. So let me move this around, and let me there we go. Hold on a second. I'm just trying to get this looking good, and I know that I'm kind of just waiting for everybody to come on in. I see some folks watching. Thanks. Good to see you. I'm doing good tonight, Jerry. Thank you. I'm just having some fun. Space junkies. Yeah, you're funny. So I'm gonna just hang out a bit here. Just give it a couple more minutes until we get the stream going, and then I will of course start going in earnest, because I'm sorry, I spent time getting the I spent time trying to get the telescope aligned, as I said, and so it's taken some time. I'm actually controlling the telescope now with my iPad, so I've got a 250 plus pounds of machine over my head that I'm using and controlling with the iPad. So it's sort of new, and I'm trying to do that. And the stream hasn't stopped. I've actually just not done anything with it. And to show you what I mean, I'll take a photograph of the object we're looking at so you can see. Here we go. Let's do 1.3 seconds. And I'm telling you all the settings because I want you to know what they are. I'm doing 1.3 seconds at an ASA of, ISO, it's the same thing, speed sensitivity of 8,000. Now, we do have a bright moon up there, so it may make a very bright image, unfortunately, but we'll see. It came out okay. You'll see it in a bit. Now this object, again, is a globular cluster, many stars, tens of thousands, sometimes over 100,000 stars. And you'll notice that the object it's got some bright light around it. That's the moonlight. It's actually very close to the full moon, and that's actually a problem. And I'm sorry about that. Being close to the full moon is an issue. But that said, I know that we can do something with this. This thing that we're looking at right here, by the way, this is Messier 5. Now, when Charles Messier in the 1700s, he created this Messier catalog of objects not to be confused with comets. This was one of them. Now, this is like an exploding snowball of stars. I'll take another photo of it, but I'm going to actually, oops, that's the wrong way. I'm going to take another photo of it, but I want to do it with a slightly lower sensitivity. All right, so I'll make it like a 4 seconds at 16,000 ASA. It'll be less grainy, less noisy, and this should be better. Let's take a look. It's counting down, it's doing its thing. There we go, that's a little better. So now you'll see that we have this looking like this now. And if we zoom in on it, all right, you can see that this looks a little bit different from the other globular cluster. If you were with us the other night that you saw, that other globular cluster was called Messier 13. And we'll go look at that one in just a second to give you an idea of what that looks like. in comparison. Now, they're both globular clusters of stars. They're like hundreds of thousands of stars together, and these are objects that are in what are called the galactic halo. They're called halo objects, meaning they go outside the normal route for stars, which are in our disk of the galaxy. There's a halo population of stars, and these stars are very, very old, among the oldest stars in our galaxy, if not the oldest. So these kinds of stars really are a glimpse into the distant past. Now, just to give you some specifics on this particular guy, this was basically stuck into the Messier catalog in 1764 by Charles Messier, and it's actually 24,000 light years away. And many globular clusters are, in fact, typically 24,000 or 20,000 plus light years away. And I think that that's really something, because it's important to actually see, that some of these objects out there in the galaxy are not really that close to us. They're not really far in some cases, but it's everything in between. So it's pretty cool. So taking away from this guy, what I'd like to do is I'm going to go look at our list I put together of tonight's best objects. I'm going to go try and now bring up one more that I think you'll like, and that is going to be Messier 13, which is the great cluster in Hercules. And I'm going to look for it here. I'm looking at my database because I'm going to be steering it to go there, and that's kind of what we want to do. And it's called the Great Hercules Cluster. And so now we're going to go. Okay, moving. All right, so now let me get out the mode here, the camera. So now coming into view, you can actually see the cluster down near the bottom of the screen, and it's I'll move it up a little bit. So now get it over into the center. This is the one we saw before, but let's take another picture, the same as we just did with the other one, the other Messier 5, and take a look at what this one looks like. They look close, but they're not the same. They look different. They have different populations of stars. All right, and now this one, okay, you'll notice, and you know what, the rotation is just a function of the camera. It's not me doing it. It's doing it by itself, so I apologize. But this is Messier 13, and we just saw Messier 4. Now let me go back and show you. Now look at Messier 13 here. Now let's go back to Messier 4. All right, and so that's this one, and there's the other one. I'm sorry, Messier 5. See the difference? That's 5, and that's 13. I mean, this one has a more compact center, but the stars are more farther apart on the outside. Messier 13 has a compact center, and the stars are relatively close, going all the way to the outside. All right, so this is something that's very characteristic. These globular clusters sometimes will lose their stars with gravitational interactions over billions of years as they circle the galaxy. So it's pretty neat, and I like that a lot. And I apologize for the lateness of this stream getting on late, but I was doing some alignment, and as you can see, it's paid off. We're getting some really nice views, not having to search too much. And we'll actually go take a look at the moon at some point as well, but that's for after. So now let's take a look. Let's go to that one's going to be a little low. I'm just looking at objects that I have set up here. Those are low. That's also low. That one, you know what? Let me just see where it's located. I'm going to bring it up on the screen here. Yeah, that's really low. That's on the horizon. Not ready yet. There was one, this nebula, but a nebula is the cloud of gas and dust and stellar nursery, and it wasn't really in a position to be shown yet. It was just too low near the horizon, unfortunately. So now let's take a look. Just a couple more things here. Let's see. Let's see where this one is. This is pretty, if we can see it. Oh boy, that's really low. Alright, you know what? We'll try it. I don't know if we're going to be able to see it too easily, but we're going to try it. This one is, if we can see it without any problem, this is called the wild duck cluster. And don't ask me why. Moving. I'm concerned we might see trees more than anything else. Let's see if it's true. Oh, maybe not. We might have lucked out. Let's see what happens here. Yeah, I'm not sure we're going to be able to see it, but let's just take a picture to see what we got. Oh, I did that. Oh, there it is. It's in there. Okay, hold on. Let me just bring it up a little bit. Okay, this is the wild duck cluster, and let me just drop down the time a little bit, and I'll drop the sensitivity, and I'll tell you what I'm doing. All right, I'm dropping the sensitivity to ASA 10,000, and I'm going to do a 2-second photo. So I'm taking the photo now. You'll see the screen go black. Okay, boop, and then come back in 2 seconds. There we go. And now you see the wild duck cluster. This is the cluster itself. What's interesting about this cluster, well, there's a lot interesting about this cluster. Let me just zoom in to show you the photo we simply just took right now. You'll notice that the cluster has some interesting colored stars in it. Okay, and I realized that it's low on the horizon, and here's what happens when things are low on the horizon. The starlight is taking some time to get to us, and when that happens, the starlight is reddened because of our atmosphere. It's made to be more red. So we're seeing exactly that here, okay? Now, it's in terms of minutes, it's basically 14 arc minutes in diameter. And you say, well, what's an arc minute? Well, there's 60 of them in a degree, and the moon is half a degree, so it's like 31 arc minutes in diameter. So this gives you an idea how big this is in the sky. It's only 14 arc minutes across. All right, and we're going to use arc minutes a lot in our journeys in the sky because, and I'll teach you what those are, as I said. So now you understand. 14 arc minutes is basically a little less than half the diameter of the full moon. All right, because the full moon again is 31 arc minutes. This is 14. So the brightness is another thing we're going to talk about a lot. The brightness of the brightness of this cluster, it's called a magnitude. The brightness. Now, magnitude is something that's a logarithmic scale. I'm not going to expect you to know what that is or remember it. Understand though that stars in the sky that have negative magnitudes are very bright. The sun is like -26. And Vega is like 0. Okay, and it's really very bright stars are very close to 0 and maybe negative a little. The cluster here, this overall cluster, is a magnitude of 6.3. All right, so that means it's visible in binoculars, but not to the naked eye unless you have this, the telescope. So here, this is kind of what it looks like in a faint or a telescope that's not too good. All right, and this is the live view, like I said. So that's what it looks like. Now, if we increase the sensitivity a little bit, this is like hugely increased to 128,000, and let's reduce the exposure to say 0.8 seconds. Let's see what we get. So it's really quick. It'll just flash, and there we go. So you see, it's similar, but there's more noise in the image, and that's again part of the digital process. When we take pictures with high sensitivities, that's what we get. You see all the little rainbowy colors. That's a combination of the atmosphere putting all kinds of stuff between us and the cluster, and it's also a function of the camera sensor being overloaded with noise. But the wild duck cluster is really rich and very compact, and it's called Messier 11, just for the record, so you know. If it sounds like we're doing a tour of the Messier objects, that's not exactly what the plan is, but I am doing that just for fun, just to kind of zip us around a little bit. Now, as I said, with full moons out like this, it's easier to do cluster searches and things like that. It's not really easy to do galactic things, but even so, it doesn't mean we can't try for them. And so that's something I think we'll try in a little while, maybe. But I want to first bring you to another cluster, which is called M39. It's Messier 39, and it's in the constellation of Cygnus. So let me get out of this with the camera. Sorry about that. Now, some clusters are very rich, like the wild duck. And then there's clusters like this, which don't seem to be very rich at all. They don't seem to have many stars, yet they do. And this is part of that whole process. That these are stars that, these are clusters that actually have, a number of stars, but you just don't see them all. Now, let's just do a photo to see what we're going to get. We're going to do another photo. We'll do this one at, say, 1 second or 1.3 seconds, and I will change the ASA, the sensitivity. We'll put it down to, say, 12,800. So here we go. Okay, and it's taking a photo, and boom, it's taking a picture, and then. So there you go. So that's what we have, and this is actually a cluster that's in the constellation of Cygnus, the Swan. This is also an area where the Milky Way is very rich. When the sky is empty of the moon, then these areas will have many more stars visible in the background. You see that it looks kind of bluish. That blue is actually due to the lighting of the sky from the moon. Now, during the day, we see a blue sky. Well, here at night, we also are seeing a blue sky. Isn't that curious? And we're seeing that specifically because the sky is being subject to the moon's effect in the same way that it's subject to the sun's effect during the day. And the reason is because we're actually looking at a sky that has nitrogen molecules in it and oxygen molecules. And the sun is not directly influencing our sky right now, except it is doing that through the moon. And I think that's pretty cool. And the moon is causing this effect we see in the sky. This is called Rayleigh scattering. All right, the reason we see blue sky, it's Rayleigh scattering. So this scattering effect is something that is really, really interesting because it promotes a blue sky even at night. So I think that's kind of cool. And I'd be willing to bet that this entire sky is nice and blue just because of that. And I'm very happy with the sky as it is now. It looks pretty, and I do believe that we would be looking at a sky that was black if we didn't have what am I saying? I'm sorry, I'm doing two things at once. I apologize. And that's down from like 6 things at once. Usually I do 6. If we were looking at this, without a moon in the sky, then the sky would look darker. But we would still have what's called sky glow. And sky glow is not the glow from sodium vapor lamps and other lamps in the sky or other pollution from the light. It's actually a process that the Earth itself causes because of the high altitude molecules in the atmosphere that are interacting and actually releasing light at night. Because during the nighttime, the molecules in the atmosphere end up emitting some light, and that light can look softly green. It can be a little yellow. You can get some sodium atoms causing a little bit of yellow, and that's not to be confused again with the sodium lamps. So I think it's pretty cool. So I would say that looking here at a little cluster like this with a blue background, you're seeing so much science in this one little view. So much science. I think it's really cool. So anyway, I would say that this was probably very good to have been seeing this tonight, because I like it. Now I'm going to go. I know, isn't it great because I like it? Now let's take a look. Let's go somewhere else. I think that and maybe we can do this. This might be cool. And if this one's available, I gotta check how high it is. Okay, this may not be high enough, but we'll try it. Again, I know I'm rushing the summer, but I want to try and find as best as I can. I want to be able to find some of these objects that are out there. Okay. What we're looking at here will probably be nothing until I take a picture. Let's find out. Alright, I don't see it. Let's see if it's even in here. I will now take a little longer picture, 2 seconds, at 12,800 sensitivity ISO. Alright, so taking the picture, and come back, and oh, it's there, but it's really faint. I will find it. I'll bring it back for you. Okay. Now, what it was another version of these globular clusters. Okay. Let's take a longer exposure, say 4 seconds at ASA 12,800. Okay, and now we're taking the picture. Boom. And we come back. And there it is. It's really faint, but I want you to see it because this points out a number of things. So now look at this. This is a globular cluster as well. But if you notice, this cluster looks very different from the others. It's not nearly as bright. All right. It seems to be about as big, maybe a little smaller, but it's not really as bright. Now this is again called, as you guessed it, a Messier number for sure. Messier 71, M71. All right. And this one, it's easy to find, but it's very faint, like as you can see. Its distance from us is only 13,000 light years, however. So you say, well, wait, how come it's so dim? And the answer has to do with what's between us and this globular cluster. And it's one of the nearest to us, but it's 27 light years across, which is kind of interesting. And it has some irregular and variable stars in it, which actually kind of means that they vary in their brightness in an irregular way. Nothing that's we can detect that's a pattern. And for a long time, people thought that this was just another open cluster that was just packed with stars, packed with just a bunch of stars. As it turns out, it's not that at all. It's really just, it's really another globular cluster. Now, the thing is, it's really called, in terms of globular clusters, it's called a loose globular cluster. So it has a number of stars that have sort of migrated away from that dense core we're used to seeing with M5 and M13 that we saw. So this globular cluster is one that's actually looks fainter, again, because of what's between us and the globular, but also because the dense core is not there, because the stars have sort of migrated away from the dense core. And this is what you get. You can see now that the additional light from many more suns that would have been in the center of this globular cluster would have actually been incredible and would have actually made this much brighter. and that's not what we see here. So that's Measure 71 or M71. Now, let's. I'm loving this alignment, by the way, because it means that now we can actually just do what we really want to do, and that's exactly what we're doing. If you can tell us, as you can see. Now, let's go. I'm looking for a couple of other things here that I think will be cool. Looking. There's a few asteroids too, but unfortunately, with the bright moon, they're not reachable. Unfortunately, I hate to tell you that, and I am sorry about that, but it's true. All right, let's see. Let's try. I told you I wasn't gonna do faint things, but you know what? I really want to try some faint things, don't you? I do. Let's just try. And I'm gonna do this. I'm gonna do this right here, and I'm not telling you what it is yet, but I will. This is a galaxy in the constellation of Leo, and it's actually one of several that are in the same area. But let's go there and see if we can actually see it, even with the bright moon. Sorry, I forgot to say it was moving. I apologize. And the squeaking, as always, is the dome. All right, let's see where we are. All right, I'm going to take an image and see if it's anywhere near here. Okay, taking the image. Oh yeah, how about that? That's pretty cool. Okay, so here's what we're going to do. I'm going to show you that. Okay. All right, now if you notice, up in the upper right, you see a galaxy. Okay, that's a galaxy. Now I know they look faint. You're used to seeing a lot different, you might be used to seeing a lot of different looks for galaxies if you've ever looked at them for the Hubble shots and stuff. But this one is actually more than one. If you notice on the left, you've got another galaxy. Because there's actually 3 in this area, and I didn't want to say anything until I could just be sure that they might be visible. And I'm actually happy that they are. So I'm going to just move here. I'm actually reaching across the observatory because my headphones are not long enough the headphone jack is not long enough to reach the back end of the scope from here. It's at one odd angle. So I apologize for that, but you know, that's changing. I bought a new cable today that I'm going to get in a day or two, and I'll put that on. So there's a galaxy there, all right, and this galaxy we're looking at is M65. It's called Measure 65, and again, discovered by Charles Messier in 1780 when he was doing his catalog, and 66 is right next to it. That's the one you saw next to it. And they're not really binocular objects, but you can kind of see them in binoculars if you have a nice dark sky. Now, these are pretty much the core of a group of galaxies within the constellation of Leo. There's a lot of galaxies in Leo, and these kind of form the core. These are actually very interesting galaxies because you know, you saw these two. Let me try and pop out just a second. I want to, again, I'm doing this from a distance, so I apologize. Okay, let me go back to the pictures. If I sort of know the buttons on the back of the camera. Is that it? Yes. Okay, there we go. All right, so on this image, you see that there is one galaxy to the upper right. There's one to the lower left there, and then there should be another one. And I might have to just move this telescope a little bit to find it, so bear with me a second. Alright, now we're going to take another photo and see what we got here. Alright, again, if you could see the contortions I'm going through to reach for the camera here, it's really funny. Okay, take the picture. We're gonna take some longer exposures too. Don't worry. All right. Well, there's the galaxies again, and let me just bring them up. There they are down there. I don't see the third. I'm probably coming at this from the wrong side. I probably have to move it. Well, the bottom line is, I first want to actually just, since we're doing this, we can focus on this, these pair of galaxies right here. Now, what are galaxies? Galaxies are effectively island universes of stars. They actually have their own. They have their own cores, and most people think that, most scientists, most researchers, we kind of believe that the galaxy these galaxies have black holes at their center. That explains why they can attract so many stars and form these cohesive pinwheels. They're like pinwheels of stars. And there's various types of galaxies. There's galaxies that are called spiral galaxies. There's galaxies that are called elliptical galaxies. And ellipticals are really neat because ellipticals will be simply featureless blobs in the sky. And these featureless blobs are actually, not so, they're not really, they're featureless to us, okay? But they're not so featureless when you consider that they have sometimes the most stars of any type of galaxy. And that's kind of cool. So I'm going to take another photo at 8 seconds. This will be an 8-second long photo at ASA, the speed of 12,800. So we're going to kind of sit back and wait for da 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 da. There we go. And then we get our 8-second photo. So let's take a look at what that looked like. All right. Now you can actually see there's some more. You can see more detail in these two galaxies, and I'll zoom in a little on these so we can check them out. There's still a little bit of noise in here. Again, there'd be a lot less if we were looking at the moonless sky. So we'll just have to deal with it. Now that bright core you see in this galaxy is actually the central core of this galaxy. It's actually fairly bright. But then that faint stuff you see going up to the upper, slightly to the upper right, slightly to the lower left, it's almost vertical. That's actually the disk of the galaxy, the disk with all the many stars. And this particular galaxy, M65, this shows us some interesting things. We can see within M65 a dark lane that is a lane of gas and dust that is that is between us and the galaxy, and it's in the galaxy. And you actually see this on really long exposures, ones that have been properly taken. So it's something that we're going to be able to see later in the season. I'm sorry, not later in the season, later in the month, when we can actually see these without the moon. Without the moon, all that glowy stuff you see on the screen, all the stuff that has the little rainbowing colors on the background will be gone. And you'll be able to see these much, much better. I promise. Okay, I've done this before. And so if we take the same photo, let's just go to the left now and look at this one. Okay, this galaxy is interesting because it looks like it's slightly farther away, but in fact it's actually it's kind of in the same general vicinity as the other one. And the only problem is that it just is a little bit fainter. It has a little bit smaller volume of stars. Again, it's sort of a spiral in the same way, but it's really kind of neat to see it because galaxies come in a lot of different variations. Our own galaxy was always thought to be a spiral galaxy, and it is for the most part, except we think it's now something called, and I did take the camera down like you saw, not down, but I just changed the got out of the picture mode. The galaxy itself is one that's in it's in a state of change. We have it's called a barred spiral, and that our galaxy has a bar in it. It's like a vertical bar that crosses the whole center line of the galaxy, and that's something we did not even know until such time as we we came along and investigated it. Now, this will be the longest picture I'm going to take of this group. It's 13 seconds at 12,800 ASA. So, you know, it'll be a black screen for a little bit of time. But I just want to see if we can coax any more data out of this. Unfortunately, I'm not able to. Oh, that looks pretty. I'm not able to see the chat right now because I'm doing not right now. I'm doing what, 5 things at once. But I can do my best to kind of get to the chat and poke around a bit, you know, as we move forward here a little bit. And let's see. Yeah, you see this galaxy now, this one that's showing up on the screen. You can see that it has a strange darkness to the left side of the bulge, to the left side of that galactic center. All right, and that is a dark lane in that galaxy as well. So it's kind of cool. And then if we go over to this other galaxy, you can see that it's starting to show a dark lane as well, right to the left of its bulge, a little bit past the left of its bulge. So with some processing and doing a special process called stacking, I'd be able to coax the data out of this. So I may very well do that. And I'm just happy as a clam that we have the ability to do this tonight, even though it's a moonlit night. So that's M65 and its companion M66 galaxies in the constellation Leo. So, you know, I will try and keep the excitement going here. Let's see what I can look for now. Okay. Let's find out. Yeah. By the way, did you know that the North Star is of course Polaris? But did you know that Polaris was actually a double star? It actually is more than one star. Yeah, it is. We're not going to go there. But you know. Now, remember when I told you about those elliptical galaxies? I said they're like featureless blobs sometimes. Well, there's another one, not too far away from these. Let's see if we can find it. Let's see if we can find it. I'm not sure, but we'll try. It's actually right near Jupiter in the sky. And let's just wait for the telescope to beep. Okay. So now I'm gonna take another photo. And let's do, say, oh, not that. Let's do at 12 point. Let's do 4 seconds at ASA 12,800. So this will be just a 4-second exposure. There it goes. You saw the screen go black. It was already pretty black. And oh, there it is. Look at that. In the upper right hand corner. Let's go get it. Let's go grab it. Alright. So, this galaxy is pretty interesting because it's actually, again, let me just get rid of the, these are just parameters from the camera. It's actually interesting to look at the, oops, it's actually interesting to look at this galaxy, if I can ever get it back, for crying out loud. Hey, thank you. Because this one actually has a little companion star that's next to it, and that star, and this is what's interesting about these. You know, we see things in the universe in this 2D format, don't we? It's like we just think that everything is at the same distance. We think the star is right there with it or whatever. But in many cases, that's not the case. You see all the stars around it, okay, you see the little stars, but then you see something right to the left of it, all right? And this is interesting here, I'll tell you this. This is called Measure 49, go figure. And M49 is actually, if you can believe it, its distance from us, you're seeing something that is 60 million light years away. You heard me right, 60 million. So we're seeing it as it was 60 million years ago, just after the dinosaurs died, basically. Okay, which happened 65 million years ago. 60 million years ago was a little more recent than that. So that's how old this is. 60 million years. That is outrageous. And of course, that just goes to show you the galaxy is big and the universe is huge, right? So, that said, it's actually a very, very massive galaxy. And it actually, if you consider how far away it is, its size in the sky, all right, tells us that it's actually on its long axis. You can see there's a longer elliptical axis than shorter. It's about 160,000 light years along that edge, along its length. And it's actually really one of the giant elliptical galaxies that exists in here. So the interesting thing too is that these things aren't all just sitting still out there. Galaxies, stars, they're all moving. The stars are rotating and orbiting. They rotate on their own axes. Our sun takes about 30 days to spin on its axis. Other stars can do that in a matter of hours and be 100 times bigger than the sun. All right, and so everything under the, I'm going to say it this way, everything under the sun is possible. That said, when we look at this elliptical galaxy, it, like others, can be speeding away from us at a high rate of speed. All right, and that tells us a lot of things. It's called redshift, and that's the speed of the objects receding away from us. So that redshift tells us something, because at 60 million light years away, this one has a speed that we acquired from getting its redshift value. It's about 570 miles per second that is going away from us. All right, that's kind of cool. And it has this this redshift. Basically, the farther away a galaxy is, the bigger its redshift is, which makes sense, because as we're looking out into a universe, we're looking at the universe younger, and so things were moving faster back then. So perhaps we're just seeing that. We're seeing a remnant of these moving objects out there, and that's kind of what's cool. Now, to the left of that elliptical galaxy is that little dot that I told you about. That little dot is actually a star in our galaxy. So that star may be only a couple thousand light years away, but the thing right next to it is 60 million light years past it in the far distance. Now that is something to think about. But that's a really cool little object in the sky, I think. Let me know what you think in the chat. I'm gonna go through it and read a lot after I get done. It's actually almost 11 o'clock. I'm gonna go a little longer. Tonight, actually, I was not gonna do streaming. I was actually gonna do testing, but I figured since I had this working so well, I'm actually gonna continue to do it. And right now, I'm gonna go to another place. Had I thought, I would have, taken this off of this mode. Yeah, I don't see anything yet. Let's take a picture. Let's see what we got there. It may or may not be in there. Oops. Oh, there we go. I was waiting, I couldn't tell. Hey, there it is. Okay, so I'll show it to you. This is another galaxy. And this one is actually a famous one. And you can't really tell, I'm sorry about that. You can't really tell what you're looking at, I know, but I will get back to it. There we go. Let me just zoom in on this. Actually, you know what? I gotta move my position. I gotta move around in the observatory to another location. There we go. Oh, I'm right in front of the camera now. Tell me, this is good, huh? So, let's zoom in on this. I want you to see this. This one, even with the moonlight, you can actually see some really interesting detail. If you notice, look in the center. You can actually see that there's actually some dark matter blocking the view from us. And you can also see that there are areas that are actually red and slightly orange. That's not an effect of the camera. That's not an effect of the speed at which we're shooting. That's real. That's actual. And this is because of the fact that we have a galaxy here that is what's called a starburst galaxy. It used to be called an exploding galaxy. It's called go figure, M82. And it's a galaxy in the Big Dipper, in Ursa Major, the constellation Ursa Major, within which the Big Dipper is a little pattern that we recognize, so we call it the Big Dipper. But in Ursa Major, there's this exploding galaxy, it's called, in the past. Now it's called a starburst galaxy. And the reason it's called a starburst galaxy is because it seems that this galaxy is undergoing a massive amount of star formation, as you probably already guessed. So let's go back a bit, and I want to actually bring it in a little better. I want to see if I can move over. Just a little. Okay, let's try that. I can't see it on the screen, so I don't know. And I'm going to go up to 6 seconds at ASA 12,800, which is working well for us tonight. And so there it goes. And now we're going to get a 6-second exposure that's starting. Pardon the noise, I'm moving my seat over here. Oh, I went a little too far. But that's okay. I'll figure it out. Wow. Okay, so let's go back to that. Let me actually, first I'm going to move it over just to get it back where I really expect it to be. And then, okay, now we'll try it again. 6 seconds at 12,800 ASA. Okay, and there we go. All right. So now, boy, I can even do longer. I'll do that. I'm just gonna go to 10 seconds. No, I'm gonna go for it. I'm gonna say 13 seconds. That'll be the longest one we do. All right, and we'll come back to that in a minute and check it out. Again, the starburst galaxy is called that because it was a change of status for this particular galaxy. We always thought the galaxy was odd looking. And right near this galaxy is another one, which is called M81. Messier 81, and Messier 82, all right, has this peculiar look to it. Now you can actually see this. Remember, all of these images we're doing are dynamic right now, live. There's no fussing around. There's no, bringing in stuff from off on a disc somewhere. This is live as we see it. But you can see now that reddish orange area in the center. This starburst location, this is where all the star formation is going on. And it's really one of these things that we just didn't really know what it was. We thought that maybe the galaxy was having some type of interaction with M81, which is actually like it. Now, this one is another galaxy that in the northern hemisphere, it never sets. Because it's in Ursa Major and other constellations that are close to the northern pole are called circumpolar. They never set. They just go down low and then come back up again. So right now, this is about as high as M82 gets. When there's no moon, the view of this galaxy is absolutely stunning. And we're going to take a look at it again when there's no moon. So this is another thing that happens when we look at galaxies like this. We're seeing them as a whole. And sometimes we actually see new stars in the galaxies. And those stars are supernova. Supernovae, there are novas that exploded. They're supernovas, the stars, big massive stars that blew up, returning the elements to the interstellar medium. And when that happens, it makes shock waves that go through the galaxy. Shock waves not of sound waves or anything, because there's no way to transmit that sound in the vacuum of space, but the shock wave of fast-moving material. And that can cause things to happen like star formation. Or the galaxy like this one here has probably interacted with this other one I told you about, M81. And we'll take a look at that one shortly. And M81 may have spurred this formation of stars that are going on right now in this galaxy. It seems odd because you can't see M81 anywhere in this view. And you say, well, wait a minute, how could that possibly interfere or cause anything to go on? Well, what we're not accounting for is the fact that billions of years have gone by, and these galaxies were closer and did pass by each other, and this starburst formation has been going on for a long time, 4 billions of years, and now we're just seeing it, of course, with our cameras. Now I can imagine you're probably asking in chat, and I can't see it, but how far away this galaxy is. It's actually 12 million light years away, as is M81, the counterpart. They're both kind of at the same distance, and they're really pretty cool. And now you can see a lot of in the northern, if you look up near the top of the image and past the orangey thing, you can see there's some really interesting black vertical knotty areas. There's like short dark streaks that come out at different angles, and those are actually, possibly we're seeing this some more edge on, and so maybe we're seeing some complex geometry formed when the actual galaxies pass near each other, M81 and M82. So it's a possibility that happened like that. Now M81 is actually 130,000 light years away from this one. All right, so that's how far they've gotten to now, and it seems like this galaxy has been affected by not just one interaction with M81 and the other galaxy I'll show you, but more than one interaction, and that's something that is really hard to understand, because we live for about 100 years at the most, and the galaxies live for billions and billions of years, so from the beginning of universe time. So it's a fascinating thing to ponder, and I love going through this and seeing what people think of it. But let's I took that picture and we'll keep it. And if anyone, there's another thing too. If people want to get access to the photos that we take in the telescope, I will make them available, and I need to know that. You need to tell me in the comments or whatever. Let me know. All right. So now I'm going to go over to M81, and hopefully we'll see it moving. You notice it's not moving too fast, because it really doesn't need to, because M81 from us looks like it's right near M82. The fact is, it's actually, like I said, 130,000 light years away from this galaxy. So let's just do a quick 4-second shot at 12,800 to make sure that we've acquired it. And if we haven't, well, we'll have to look for it, won't we? So we're doing it now. There it is. So there's M81, and let me just bring that in just to show you real quick here. M81 is a spiral galaxy, and you can't really tell from this. I might, again, with a moonless night, you actually would, but let me just come back out a minute. Let me drop it down a little bit in the view, and make sure we can. All right, let's try that. Another 4-second shot at 12,800. I might go up to a higher photo value to try a higher exposure number. All right, that's a little better. And I still want to see if I can do that a little better. I can see it. There we go. All right. Now here's another thing about telescopes. The view in telescopes is generally better in the center of the field. The reason is curved lenses can cause interesting effects on the edges of the field. So stars might look like they're a little dragged out at the edge. Okay, that's called coma, and you don't want stars in a coma, believe me. And so that's interesting because of what we're seeing here now. What I'd like to do is I want to just take another longer exposure. So I'll go to 10 seconds at the same setting. Actually, I'm going to go up on the setting too in the ASA. I'm going to go up to 16,000 ASA in 10 seconds. 10 seconds. This is M81, Great Spiral Galaxy in Ursa Major. So we're taking our picture. It'll come back. It'll briefly flash on the screen, and then of course I'm going to go into the quick shot to show you. All right, there we go. And now if I come back and zoom in, let's see what we got. Yeah, I could, the moon is definitely causing issues. Definitely. So you can kind of squint and see the extent of it. And I do have image processing tools to actually work with this and make it show itself far better than we're seeing it. And I can do that, but I really think it's beneficial to show you the raw imagery. And this is raw imagery right out of the camera as it's happening. Because this is the SkyTour LiveStream. Of course, it sounds like that should have gone to like a commercial, doesn't it? Like, and now, a word from our sponsors, which is kind of funny. Anyway, I could very well be talking to myself if everybody's left the stream. I have no idea. But I'm going to go in again and try to find another interesting object to find for tonight. I didn't think the galaxies would be too good because of the moon, but, as I discovered, they're actually not that bad. It's not that bad. And I'm going to look at something else here. You notice I don't tell you what that is because if it doesn't look that good, I don't want to bring it up. But I will. We might have an issue with the moon. No, actually we won't. I think the moon will be far enough away. Okay, we're going to go to this. And we're moving. And the dome is turning to give us some blank sky instead of being trapped. Alright. Now, you won't see anything yet. And as far as, for all I know, you may not see anything when I actually take an exposure, but we can try. Alright, so let's do this. Let's get an exposure going here. And one thing you're finding out, I'm sure, is that whenever we do stuff like this, we end up finding ourselves in a position where we're looking for objects that are fainter than we can actually see. And that's a problem. But you know what? We live with it. We work best in these conditions. Alright, 4 seconds at 16,000. And this is supposed to be a chain of galaxies. We might see more than one, we might not. Okay, we do. There's at least 2 in there. Let me point those out to you. I wish it wouldn't rotate the view, and I'm going to have to investigate why it's doing that and make it change. Okay, so here we go. Okay, right there on the left of the screen, you've got one galaxy, right? And it's right to the right of a star. And then right there we got another. And then above we have another, and that's to the right. Okay, this is called the Markarian chain, and it's actually a chain of galaxies. Okay, there's did I show you that one yet? I don't think, maybe I did. Okay, the Markarian chain is interesting because there's a number of galaxies that you can see all in one view. All right, and they're just beautiful. Now again, I'm over anxious and zealous because I want to show these things to you, but naturally we need to have a sky that's a little bit dark for these, and I apologize, but I just think it's kind of cool. I think that it's really neat, and let's take a look and see if we can find another one here. What's this one? Just a minute. Okay, this one may be pretty. Let's go there. This was another potential galaxy that I want to show you, and I know I'm kind of rushing this with this, but it's right nearby. All right, and this one, let's hope it's in there. All right, now let's do a quick exposure and see if it's there. This will be a 4-second exposure at ASA 16,000. Oh, it's faint. Oh, look at that. Ha! Well, that's interesting. I think the most interesting thing about this is not that we actually got the galaxy, which is there down the bottom, but I think you're probably all noticing that there's also this strange dashed line. Okay, and what do you suppose that is? Yeah, I'm sure you're saying it in the chat. I can't see the chat, but that is a satellite, and in 4 seconds, it made that whole trail. So that's a satellite caught in here, just like that. Now, if it was any brighter, we could have just run the video and captured it on video, and then you'd see that. And I could even play that video for you too live, right after capturing it. And we'll come back to that. So there is what this is called the Coma Pinwheel Galaxy, and I'll just do a slightly longer exposure just to see if we can actually find some more detail in there. Okay, so let's go 10 seconds, and I'm going to stay at 16,000. All right, so we're taking a picture. Now we're exposing, so the screen's going to be blank. We're doing it for 10 seconds. And who knows, maybe we'll see more satellites. Okay, well, we didn't see any more satellites, but we did see that there is, we saw the galaxy a little bit clearer, and I'll have to, again, make that effort for doing this when we're without a moon. Okay, so we have a star in here, and we drop down, oh, we just passed it, and there it is. Now, I think that's pretty cool. But you can't really see the pinwheel easily because we have this bright moon. But I do want to go to one that does show us something a little bit more detailed. By the way, just so you know, this galaxy we're seeing is about 42 million light years away. All right, and that's pretty impressive considering that it's relatively small. And this one again is called M99. There's that Messier number again. Messier 99, not to be mistaken as a comet. And this is in the constellation of Virgo. What's interesting is Virgo has a lot of galaxies in it, and of all the galaxies in that constellation, this one has the largest redshift value, showing that it's receding from us, leaving us, going away from us at 2,380 kilometers per second. That's a huge distance. And when we do angular measurements of the galaxy, and given its distance, it's at least the diameter of this galaxy is at least 95,000 light years. All right, so it's, our galaxy's much bigger than that, but still, we can see this here, and it's got probably 53 billion stars in it. We have between 100 and 400 billion stars, so we're a lot bigger. So it's just a faint blob, and you go, what the heck? It's just a faint blob, and I agree. But that galaxy has some fascinating, history to it, especially because of its redshift. But what I want to do now is show you one that's actually a little more visible, a little more interesting, and I think you'll like it a lot, as long as I can find it. Let's make sure we can find it, shall we? Alright, so here we go, we're going to that, so moving. Okay, and as before, we can't really see it, but let's see if we can take a picture of it, shall we? This will be 8 seconds at 32,000 ASA. So for 8 seconds, we're exposing. Oh, look at that. Too bad the moonlight's there. Let me bring it up for you so you can actually see it. Okay, now we're actually seeing we're seeing a very interesting galaxy. This one is called M51. It's called the Whirlpool Galaxy. This one you can actually see the shape of this galaxy. You can actually see that it's actually got a shape that is very much so a spirally shape, and you can see that it has another little galaxy to its right. That galaxy is actually connected to it through a faint tail that you can just barely see. And I'm going to work on trying to get that tail to come out, okay? Because maybe we can see it with enough, a little bit of work here. And it's, again, we're fighting the moon. And as I said, I don't know why I'm doing this with the moon out. I think it's because I can, and it's working. So let's go up to, we're going to go to 10 seconds on this. And I'm going to take a picture of it now, but let me see, it's on, it's actually, where was it? Let me get it again. Just want to look at it on the picture on the thing here. Yeah, that's good enough. All right, so, all right, this is 10 seconds at ASA 13,000. Now, the Whirlpool Galaxy is a really neat galaxy because it's in the constellation of what's called Canis Venatici or Canis Venatici, and you can see when we go back into it, you can see that the galaxy itself, where is it? Come on, give me. What's going on here? Where is it? Oh, sorry. You can see that the galaxy itself is a spiral galaxy. You can see that. A little hard to see, but you can see those spiral arms around the left central bulge of that there. And this galaxy is 28 million light years away. For comparison, the Andromeda Galaxy, which some of you know about, is 2 million light years away. This is 28 million light years away, and it's really quite stunning. And every bit of that blue and kind of rainbowing you see is because of the moon. Without the moon, this is going to look so much different and so much brighter. But this is really cool. Now, you can see that the M51, this is called the Whirlpool Galaxy, actually. The Whirlpool Galaxy has a spiral pattern, and that spiral pattern wasn't even seen until 1845. All right, when a guy named Lord Ross actually saw it with his, are you ready for this? 6-foot reflector at Parsonstown, Ireland. Now, he made a very accurate painting of M51, which is the only way that they were able to record these things, back then, easily. Because photography and fast films just didn't exist yet. But the thing that they said was they referred to this as Lord Ross's galaxy, or as the question mark, Ross's question mark, because it kind of looks like a question mark. And if you grew up during the Batman era, then you might say it's the Riddler galaxy, which is cool. And what's neat is the spiral pattern. The spiral pattern in galaxies forms, of course, because we have objects orbiting them. But then there's other reasons why these spiral arms form. The spiral arms can form from waves, shock waves, moving through the galaxy, and they could also form from objects being swept out. And those objects farther away orbit at a slower speed, so that's why the arms look like they spiral. This is something that people have often talked about. Now, this is a face-on galaxy. We're looking down on top of it, basically. And because of that, we can see pretty much most of the stars in the galaxy. And because of that, we've actually been able to see supernovae in this galaxy. So far, there's been 2 that have been discovered in our history. One was in 1994, and one was in 2005. So there are some fairly massive stars in the Whirlpool galaxy that are exploding and delivering elements back to the interstellar medium. So this is a neat galaxy. It's actually fairly clear. You can see some Hubble shots of it eventually, and if you look them up, Hubble shots of the Whirlpool galaxy, you look that up, and you will see the central core of this galaxy has knots of red and beautiful star-forming regions. Those are called H2 regions. That's H double, numeral, Roman numeral 2, H2. That means doubly ionized hydrogen. And that just means that hydrogen gas that's not in its regular normal atomic state. It's been ionized. So in that case, that when hydrogen gets ionized like that, it gets brought up to a higher energy level, and then the atoms of hydrogen spontaneously they want to come back to level, so they actually emit light to come back down to their original level. And when they do that, the light is red for the hydrogen, and that's why these hydrogen 2, these H2 regions are red, and they stand out. And whenever you see them, it's a good bet that there's star formation going on, because these H2 regions have been associated with star formation for centuries. So it's pretty neat. And the Hubble actually took a view of the central core, the left core, the one that you see there on the left of this galaxy, and focused on trying to get a good view of the dust and the H2 regions. And it's really beautiful. You can actually look this up and see for yourself. And I took a photo. I took actually about 15 photos of it one night, on a moonless night. And then I did something called stacking, where I actually, in software, I actually stacked them on top of each other to get a final image that had more signal, that is more galaxy light than noise light from the noise of the camera. And that's stacking improves the signal to noise ratio on your photos that you take. And so I stacked these 15 together, and then I did some image processing for about an hour or two, and it brought out the detail. And I did a Facebook post a while ago that you might have seen, which actually shows the Whirlpool galaxy in all its splendor. With you can see these H2 regions in the center like that. You can see the knotty black dark dust that's in there. Really, it's just amazing. And so I'm really happy with that, and I think that the Whirlpool galaxy is a really cool object for us to have found tonight, in spite of the moon. So I got to tell you, and I've said this before, and yes, I haven't killed the camera here. I'm actually I'm still active. It's just that I can see a star over there on the left. I've just dropped out of the picture mode. So it's really interesting to be able to see these galaxies, and as the summer wears on here, and we have many more objects to be able to view, I think we're going to have a really good time. And now I'm going to bring this to something that we all know and are very familiar with, and that will be it'll be something that we're going to end the stream on, I think, and I hope you can appreciate it. Actually, you will. Well, actually, you know what? I'm gonna do this. Hang on. Let me just go find what I'm looking for. Where are you? It's odd having to find it, but you know what? I don't have to find it. I can just go there. 1 second. I'll just go there. I'm depending on the iPad way too much. But look, it took me effort to actually get this all aligned. I mean, you saw every object we tried to find was right there, and that's testament not to my prowess. I mean, maybe a little bit, but yeah, obviously the real prowess comes from the fact that the telescope was really nicely aligned, and I did spend time to align it, and that's where any effort I put into it comes from. But it really is a beautiful scope and gives us a lot of interesting views. All right, so we're moving to the next object now. and I hope that you will appreciate this one. I think you will. Actually, we don't want to do that. Sorry, I was just okay. I was trying to move the telescope and it did not go where I wanted it to, but 1 second, I will take care of that in just a few minutes here. That's easy enough to do. 1 second. Or as Hal says in 2001, just a minute, just a minute. And then he says, Dave, I'm afraid there's going to be a failure on antenna number, and whatever he says. I think it's pretty cool. Hey, what's that? I got clouds out there. I can't believe I got clouds out there. I'm not supposed to have clouds tonight, for crying out loud. Alright. Alright. We're moving the telescope down now, because I'm going to show you something that you're familiar with and you know. So, patience. Patience, one and all. Oh boy, what's going on? It's so bright, isn't it? Yes, as you can guess, I'm bringing us over to the moon. Because my understanding was I talked to Paul earlier tonight, and sorry, not Paul. I talked to Keith, and he suggested that Paul wasn't going to be able to stream the stream tonight. Okay, 1 second. That was oddly wrong. I'm just trying to get this thing to go to where I want it to go, and it gave me a hassle for some reason. Didn't give me a hassle when it came time to do these things before. That just gave me a hassle here. Okay, let's go back. Okay. It's a supernova. Oh my god. Yes, it's very bright. Oh my. Yeah, okay. I'm going to bring down ASA and bring down all the brightness to make this a little bit more manageable. And bring down the exposure a little bit. And 1 second while I bring it in. Let's see here. There we go. Alright. Look at that. Oh wow, moon. Yeah. Doesn't look much like the moon until I do this. And I bring it down. Ah, yes. There we go. See, now we have the moon in there. And it's actually not quite full. It's like a 98% or something like that tonight. I'm not sure. It's close. But here we go. And let's do this. Let's bring it in. And now I'm going to get critical focus, I'm going to zoom in, which I like to do. I'm taking a picture first of all. Alright, it'll just blink. There we go. And then I can zoom in. Now let me go over and do some focusing. Wow. Isn't the moon fun sometimes? It's just fun sometimes. Alright, now I'm going to focus. I'm going to use I have an internal focus system on the telescope, so I can actually focus without touching it. And that's the noise you're going to hear. Alright. That's actually pretty good right there. Alright, so now we actually have a nicely focused moon, and if we want to pop out of that, I'm touching the camera there, that's why it's doing that. You can see it's not quite round, but there it is. It's pretty, isn't it? You notice along the down to the bottom, and I'll center it. kind of centered there. You see that big crater? You can actually see that the splash it made, the rays are called, emanating out from it. They go hundreds of miles on the moon. Now, that's of course the crater Tycho. And I actually had a greyhound dog named Tycho. I didn't race them. I just had them. I took them from the track. And I had Tycho and I had Kepler. And indeed, there are craters called Tycho and Kepler on the moon, obviously. So Tycho is a crater that is it's rayed, as I said, and it's a result of course, a large impact. But you can see how far that stuff went, and you say, well, wow, that went quite a distance. Now, if you put the moon over the United States, it's going to be about the size of the United States, straight across. But you look at this and you say, how could in fact how could that moon actually have such large ray structure? And of course, some of you already know the answer to that, and the answer is because the moon has very low gravity. And because the gravity is so low, it's 1/6 ours. Because the gravity is so low, we don't recognize as normally we don't recognize that we actually have the ability of lunar material it can leave a crater and go flying off the moon at a high rate of speed, and then the moon's gravity slowly brings it back down. It doesn't bring it back down immediately because, of course, there's no air to stop it. I mean, there's no air to slow it down. That's another one of those things. Without air to slow it down, you don't get this material raining out of the sky like fairly close to the impact, like what happened on the Earth and like has happened on the Earth. So in this case, we just have these rayed craters that have the long extensive patterns because of the fact that the material has been able to stay airborne, so to speak, off the moon and up in space, and then slowly comes down. Now, you also notice that there's some bright reflections at different points of the moon, and I just want to bring up some of these. Okay. Now, if we just come up a little bit, and if we go over, okay, you'll see right there in the center there's a little tiny bright spot there that looks kind of odd, doesn't it? Okay, that is actually an area where the sun just happens to be reflecting at such an angle that it's sending most of the light from that crater back to us. Now, that's probably the result, or most likely the result, of the crater being set so that the reflection off of the bottom of that crater or off the side walls of that crater will be coming right to our eyes. So that's just the geometry at play here. When we see the geometry of the crater's morphology, the shape of the bottom of the crater, that's why they're reflecting at us. That's why we see some craters that actually look that way to us. All right, and there's a number of them. This isn't the only one. Okay, if you look over the face of the moon, okay, you can see that there's actually some fairly bright ones. Okay, like right there over here. I don't actually know what that crater's name is. I'm sorry. I'm trying to. I don't know. But right there at the bottom of that Maria, that big round dark gray area, there's another one, and it also has rays emanating from it. But while I'm there, let's talk about that gray Maria that we're seeing. So that's that thing right there in the center of the view. That round Maria is the site of an ancient massive impact, and there may have been craters there, but then something massively impacted the moon at that point, probably billions of years ago, and it ended up having the subsequent lava from underneath. As the object hit, it made the it made the surface molten, and the interior was molten perhaps, and that material just welled up out of the interior and settled over the entire area. And stayed relatively within the shape of the impact basin, which is what this was. And that's why we see this. And similarly, if we go over here, you see one over there too, on the edge of the moon up there. And again, if we go down, we also see there's one, and there's a second one. There's two right there on this side. So these, you can see there's major impacts going on here on the moon. There's one, actually, there's also one right here. Let me go over and go up a little. Oops, sorry, I hit the wrong thing. So you see right there, there's one right there. That's one as well. So the moon ended up having these massive impact structures from which the craters were filled in with, the impacts were filled in with lava and molten material from inside the moon. Then sometimes they got to the point where they simply overlap so much that you can't even really tell. Something like this area, okay? Many different impacts hit there and overflooded the moon with lava and filled in craters, and probably erased craters. We'll never know we're there. And you can see Tycho is really fascinating, because Tycho is an area where there was a massive impact, and that massive impact was such that, let me just do this again here. I'm trying to get in. Where am I going here? Sorry, I'm trying to. It was a massive impact, and come on. Okay, my camera's playing weird tricks. I don't like what it's doing. Alright. Oh, I'm sorry, I get it now. It won't do it again. So now, if I, yeah, see, here's what I did. I actually recorded a video by accident. Duh. Okay. But let me show you. When we, I was hitting the wrong button, I apologize. Alright, here we go. There we go. Okay, so if we come in now and we zoom in, okay, now that's Tycho, and you can see there's a little shimmering going on because of the atmosphere, but the moon's fairly high in the sky. It's actually not bad at all. It's actually about 31 degrees up into the sky right now. It's actually 31 degrees 32 minutes up in the sky, and you can see the impact there, and then a lot of that material is actually reflecting enough light back to us that it looks like it's bright, and that's something that is a problem that always plagues us. The full moon, most of the light that hits it is bouncing back toward us, so that kind of makes it bad to view the moon. Only near the edges like this do we actually see that we can still see some shadows, and this is what we're seeing over here. Still seeing some shadows because they're near the edge. Now, I wanted to show you something else too, which I think you might actually like. We come over here. Okay, this right here, that, sorry, the wrong button. This crater right here. Okay, many of you may know what that crater is. See that circular dark gray crater? That's called Plato, and Plato is 60 miles across, right? And it's a flat bottom crater, at least it appears to be flat bottom, right? Well, the truth is, when you're in Plato, there's actually a lot of micro craters that actually came from meteors that struck after the meteor struck that created Plato. Okay, and on one of the other streams we talked about how when we look at things like this, when we look at the moon, we can tell based on how it looks, when things happen, the morphology of, and chronology rather, of when these craters actually happen. So when you look inside Plato, you'd see a lot of other small craters. You also see some different terrain. It's not totally smooth like it may appear, but Plato does have interesting morphology because of the fact that it's a perfect circle. It means that the impact was probably straight down onto it, and when it occurred, material was nice and neatly taken out, no rays, and it might have hit at a slightly slower speed, but enough to puncture into the interior where it was molten, and then it overflooded the area where it impacted, and on impact, whenever a meteor hits, or an asteroid, whenever it hits the moon, the impact speed and the energy gets turned into heat, and that's why rock and everything can be melted very, very easily when there's an asteroid impact or a meteor impact. Okay, You know, you see in our atmosphere, you see meteors burn up. And you know, the size of the meteors that you see in the sky when you see like the Perseids during August, right? Or the Leonids in, I think, November. When you're watching these, you're actually seeing objects that are no bigger than a grain of sand, by and large. Big ones that are very, very big, you know, when I say very big, the size of your fist or the size of a softball or a basketball, they routinely hit the Earth as well. But they tend to leave a train behind them. I don't mean a train as in choo-choo, you know. That was my battery dying now. Sorry. I'll replace it. They don't tend to leave they leave a train, rather. Sorry. And this train is a section of sky that's filled with the debris and the ablated material. Ablation is you know, the heated material that's coming off the meteor that is actually then set to, you know, goes behind it, and you actually see it as what looks like a trail in the sky. There was a famous Russian meteor that most of you know about, and that Russian meteor came in and hit the atmosphere, caused shock waves in where is it, Kazakhstan or wherever it was, and it ended up causing doors to be blown in, and people were knocked down. It actually caused a severe amount of damage. That's pretty darn impressive for a meteor, you know. So when Plato was formed, you know, there's no atmosphere. They wouldn't have seen a train in the sky. It just would have hit. It would have hit hard. And it actually made a nice, neat hole in the moon, which actually basically bled lava. And that lava filled in that nice circular spot, and it was perfect. So Plato stands out for that reason, because it's clean. There's no contamination from other meteors that hit nearby. You don't see you don't see Plato actually having or any other Plato having any other meteor intersecting it, any other crater intersecting it. That's kind of odd, you know, that it doesn't do that. It doesn't have anything else. Because when you look at the moon, you see that very rarely are there craters that actually can stand on their own without some type of interaction with something else, you know. And you know, there's another example, by the way, of a crater that's reflecting much of the light that's hitting it right back to us. And that's actually that's probably partially due to the camera. Let me just zoom out a bit and drop this down for purposes of analysis, and let's just go and get closer and see. Yeah, see, now you can see a little easier. Okay, that's actually a circular crater, kind of sort of approaching an edge, you know, on edge. It's kind of an oblique view to us right now, and you can actually see that you know, right now it doesn't look all like it's reflecting that much, but it does relative to the rest. Okay, it's also in the middle of a maria, and so when it's in the middle of a maria, that is a sea, it looks brighter. So I think that's interesting how that's worked out. So that's interesting. And you know, I kind of never get tired of looking at the moon. I got to thank Paul and Keith from P&K Space Imaging, who are my partners in all this. And you know, I think we just want to bring you the best there is. You know, we want to show you the sky. We want to show you the universe in ways that you just haven't seen it. And I just hope tonight we hit a number of objects. I hope tonight was, you know, interesting enough for you to hang out and to enjoy. But leave me feedback so I know. So I'll either keep doing it or I'll just slink away into a corner and just kind of curl up and say they didn't like me or whatever. Anyway, I hope that this was fun for you. And I'm going to just come out to the full moon here a little bit. If I can just get my thing. There we go. And I'll move it over a little so you have the whole moon in there. And then there we go. Come on, you're going the wrong way. What are you doing? There we go. And while I got that like that, I'll just come over and peek into the chat and see what's going on. See if there's even, you know, see what's happening there. Oh, cool. So, yeah. So I just want to, say, thanks a lot for, sticking with me tonight and hanging out. I had a good time showing you a few things, and this stream is going to be recorded, obviously, and you're going to be able to come back and check it out. And I hope that you will come back again and visit. And I hope that you had a good time. So let me know, and I hope to do this again on the next clear night. All right. So I will talk to you sometime later, I guess, and I will be ending the stream. All right. So good night, and thank you for all of your attention. All right. See you later.